So, hello everyone. My name is Piero Sanchez. I'm from the blockchain team of Wolfram Research South America. And as part of this presentation, I want to show you how to connect a new blockchain to the Wolfram language. So let's start with a quick overview of what's already implemented, the blockchain functions that we have in the language. We have a set of both reading and writing functions here that we can use to interact with a particular blockchain. So just to make a quick overview here, the blockchain data functions allowed us to see some general information about a blockchain. We can use blockchain block data to get information about a particular block inside of the blockchain. And as a block is a list of transactions, we can use transaction data, blockchain transaction data, to get information about one of those transactions. So what if we want to make our own transaction? We can use blockchain transaction, this function, to create our transaction, then blockchain transaction sign to sign it with our private keys, and blockchain transaction submit to send it to the blockchain. So all of these functions, here are some examples. First one is blockchain data for the ARC blockchain. We can see some stuff like fee statistics and the latest block ID. We can use blockchain block data with the Ethereum blockchain to get a particular block and get the timestamp, the block, the byte count, and the list of transactions here. Here's another example with blockchain transaction data for the Bitcoin blockchain with a particular transaction ID. We can get information like the fee in this transaction, the total output and input, and the block hash of this transaction. Okay, so here's a list of the blockchains that are already implemented on the blockchain of the Wolfram language. Here, as you can see, all of this option here, blockchain base, with a string value, is used to select those blockchains. All of those string values correspond to this list, and we are currently planning on expanding this list in the future. Okay, so this process of implementing a new blockchain, the way we do it is it costs on development time and also on some resources like storage. So we're offering now a new alternative for people to implement their own blockchains with our language. So I'm going to do a demonstration of what that looks like. Right. So to do that, I'll need this tool that's currently in development called the Blockchain Resource Definition Notebook. This is here's the structure of this notebook, as you can see it here. So I'm just going to go over this quickly, and then I'm going to go step by step. So at the top, we have the general information of the blockchain details, like how to connect to that blockchain. Then we have the list of the endpoints to get the raw data for this blockchain, like the block data or the transaction data. Here I can add more endpoints and I can test them here. And then we have sections for each of the blockchain functions, like blockchain data, where I can create my own request here and have a better format for it, add some documentation and some examples. And this will be the same for each of the blockchain functions, blockchain data, block data, transaction data, and so on. And finally, at the bottom, I have a section for additional submission notes. So how can I use this definition notebook, right? Okay. So what's the objective here? The objective is to connect a public blockchain API to our blockchain functions. And how do I do it? I have to fill in the definition notebook with the raw data endpoints of the API. Then I have to create a request function with the correct format for each of those blockchain functions. Then I can add some documentation and examples for each function, and finally deploy the resulting resource object for testing and submit it to the blockchain repository for review. So this last step I will cover it later, but now let's focus on this example. Okay, so I will be integrating the Dash blockchain through a public API. Here I have. So I will start by changing the name and adding a quick description here. I could add more details here if I want to, but let's focus on the blockchain-based URL. So this is the URL for the block cipher public API. So if I go to this site for the documentation, I have it right here. Yes, just to check it out. We can see that there's multiple endpoints for each of these data structures, like the blocks, the transactions over here, addresses. So I'm going to focus just on the general information of the blockchain data function and the block data function. So let's start with the blockchain data. I see also here that this is the base URL, and all of the other endpoints just go from this /main by adding this another path here, right? So this is why this is just the slash path. Okay, so here I have the block cipher API base URL and documentation, and here this is the HTTP request function that we're going to use on the background. You could change it if you want to, but this is just for you to know that we're using all of these inputs come from this form down here. So by adding a new endpoint, what I want to do here is change the name to something like raw blockchain data. The path, like on the documentation, is just this slash. It was a get method, and it had no other parameters here. Here I could override the request function if I wanted to, but let's just leave it like that. And by hitting save, I am now saving the raw request. So I could test it here. I'll just copy this. This symbol, resource blockchain, is a new symbol that we're going to use inside of this definition notebook to test the resource object. So the idea of this notebook as a whole is to finally create, right, and deploy a resulting resource object. And this small symbol here, I can execute it here. This symbol here is the representation of the resource object created from this definition notebook. So when I deploy it at the end, I will get this resource object. And this is just like a preview, okay? So this visual representation here is just for me to test it. So I'll just leave this symbol here, and I will use the name I just created, blockchain data. And it had no other parameters, so I'll just leave this one empty. And there it is. I have here the general information about the Dash blockchain that I'm getting just like I can see here, right? Oops, here it is. Yeah, so I'm just getting the raw information, the raw data. So let's do the same for another endpoint. I'll just click this button and I will add a new endpoint. I will change it to raw block data. And I'll have to see the documentation again. Here I have that the path is a little bit longer. It has blocks, and then you add as a path parameter the block hash or the block height, I believe, down here. But both of these endpoints have the same structure at the end. So this is a method, a get method, and it has some query parameters. So let's add this here. And to add a query parameter like the block, I can use this symbol and just give it a name like block. Specify get method, and I could add some parameters. So like just the names, 6 start and limit. Yes, I believe these are used for going through the pages of the results for the transactions. And now just save it. Okay, so once again, I can test it down here. This is block data, and I have some parameters now. I have the block I want to use. For example, this block, and those transaction start. This is just where to start the pages, and the limit. Like 2 transactions. Okay. Yeah, and here it is. I have this particular block and all of the information that block cipher gives me as an association. So I'm basically ready to go ahead and create my own format for the output. And I'll do that down here. So I go to blockchain data. And I will add, I have here what I want to do here is set this new request blockchain data with a function that uses the raw request. So in this case, I have it here like this. Okay, so I'm just creating this blockchain data request with no parameters, no extra parameters. And inside of this function, I'm calling the raw request, raw blockchain data, and I'm just doing like building an association with a better format here. So I just run this, and now it's added to the current resource object, and I could test it. Yes, and there it is. So it's much cleaner. You can use a data set like I was using in those previous examples and get something pretty similar to the Bitcoin blockchain, for example. Okay, so these are keywords. Actually, the blockchain data request name is a keyword, and if we're setting it to this keyword, we can now seamlessly integrate this with the blockchain data function instead of using the resource blockchain. I can just use this and specifying the blockchain base is, instead of using a string like Bitcoin, I'm using the resource object itself as the blockchain base. So if I run this, it should be getting the information for the Dash blockchain. Yes, there it is. Okay. And I could also use, I can get a particular field here, like the last block ID. And all of this is working fine. Okay, so let's do the same for the blockchain block data request. That's a little bit more complex. But the idea is the same. We want to make a request definition. This one has some parameters like the block, can be an integer or string. I can make some validation here. And I get, once again, the raw request inside. Even if I had multiple raw requests for the same blockchain block data function, I could just add them here. And what I want to do is get a final association with the fields that I want, like the timestamp. I could add it like as an data object, or the byte size as a quantity. And then by running this, let's test it here, and we can just change this with a particular block. Okay, so I have it here, data set to see it better, and there it is. This particular block with a timestamp, byte size. I could change this if I want to, however I want. And also, again, because I'm using the blockchain block data keyword here as the request name, it will just work with the blockchain block data function itself and the resource object as the blockchain base. So here, let's use the number one. Yes, it's the same result. Okay. And I could use the hash if I want, right? And again, take a property like timestamp if I want to see only the timestamp. Yes, so there it is. So this process is the same for all of the other requests, blockchain functions, transaction data, address data. Finally, I could add some more notes about myself and what I'm integrating. And now I'm going to show you how to deploy what we have so far. So I could do this up here. I could use locally on this computer, or for publicly or privately on my cloud account. So let's do a local deployment. This will take a while. Yes, okay, so here is the resource object, the final resource object. I'll just copy this and open a new notebook, because now we technically don't need this definition notebook anymore. All of the information is contained inside of this resource object. So I'll just call it set a variable here. Yes, so this indicates that it's a local one, and it has some more fields inside. Actually, I could look at which requests are inside here. The row requests and the requests, blockchain block data and blockchain data. Then I can just use blockchain data, specify blockchain base, and instead of these strings, I just use the object itself, right? And there you go. You could even like send it to another person, this object itself, and they could just start using your blockchain integration. So similarly, I'll do the same with the cloud, in this case for the publicly on the cloud. Okay, and to see that here, it opens a new page where I can see the documentation. So this is similar to the function repository. I'll talk about that in a bit. But this documentation is taken from this definition notebook itself. So now I have this resource object that comes from a cloud object this time. Oops, sorry. Yes. So now this is a resource object. This denotes that it's a cloud object. And I can do the same blockchain block data this time, if I want to, with a particular block and the blockchain base is this cloud object here. Okay, and all of this is working in a very simple way. Yes. Okay, so this is the final step, the deployment of the resource object. And just as some closing remarks. So once again, the whole process of integrating a new blockchain on the Wolfram language is a demanding process in terms of development and storage. So we're offering this new service as an alternative for the developers to submit their blockchain integrations to what's going to be the blockchain repository for review. So if we check this is actually very similar to the function repository. This is the Wolfram function repository where people can send in some functions and you can look at the documentation of those functions. Oops, not loading. But the idea is that you can create your own function using the function definition notebook. That's very similar to our definition notebook, and just submit them to the Wolfram function repository. So we're planning to do something very similar with the blockchain repository, so developers can start submitting them, and the blockchain team can start reviewing them, and in the future add them to the repository itself. Okay. So yeah, that's about it. Thanks a lot. Maybe I have some questions.
Looks like there's been questions in the Pathable chat.
Yeah, I'm seeing that. Okay. David De Broda asked me, does it cost anything to place a record on a blockchain? Or can I create my own blockchain? Are used some audio issues. So just to specify, this will not allow anyone to create their own blockchain. This is for developers of an already created blockchain that want to integrate their technology with the Wolfram language, but by using the definition notebook, instead of asking us to do the work, we're letting them do the implementation themselves, and we will review it and add it. So it's just a simplification of the process, and like I say, it's an alternative to the other the integration that we already do with blockchains like Arc and Bitcoin. Okay. Yes, people are asking about how do I create a new blockchain. Yes, again, this is mostly for the connection of our already existing blockchain. And let's see some more questions. I think Christian, that's also on the blockchain team, is already answering some of these questions. Yes. So maybe if anybody has some more technical questions about the process. Like I said, this was more of a demonstration of how the tool is currently working, right? This will be available most likely before the end of this year, and mostly for like blockchain companies that want to start tinkering with this. So are there any other questions maybe in this chat? Yeah, okay. So I think that's it.